When we conjure images of deserts, our minds often drift to vast expanses of sand dunes under the scorching sun, landscapes devoid of vegetation due to their extreme aridity. This typical desert imagery, however, masks a more nuanced understanding of what constitutes a desert. The revelation that the world's largest desert is actually Antarctica, a realm of ice and snow rather than sand and sun, challenges and expands our conceptual boundaries of deserts. This counterintuitive fact opens up a fascinating exploration into climatological, geographical, and ecological aspects that define deserts, alongside a deeper dive into the unique characteristics that qualify Antarctica as the most expansive desert on Earth. Deserts are scientifically classified not by their sandiness or temperature but by their aridity. The criterion for a desert is an area that receives less than 250 millimeters, about 10 inches, of precipitation per year, whether that precipitation comes in the form of rain or snow. This definition broadens the scope of what can be considered a desert, encompassing the polar ice caps alongside more traditional, hot deserts like the Sahara. Antarctica, the coldest place on Earth, receives an average annual precipitation of just about 50 millimeters, 2 inches, in its interior, far below the threshold for desert classification, making it the largest desert on the planet, covering an area of 14 million square kilometers, about 5.4 million square miles. Understanding Antarctica's classification as a desert requires an exploration into its climatic conditions. The continent is enveloped in ice, with temperatures that can plummet to 89.2 degrees Celsius, 128.6 degrees Fahrenheit, creating an environment where moisture is locked away in the form of ice and snow. The cold does not just freeze water but also significantly reduces the moisture-holding capacity of the air. This leads to extremely dry conditions, with most of the continent receiving remarkably little snowfall annually. The katabatic winds, descending from the high central plateau to the coastal areas, further exacerbate these dry conditions by evaporating any moisture present in the air. This unique combination of cold, wind, and low precipitation cements Antarctica's status as a desert, albeit one starkly different from the hot deserts found in other parts of the world. The ecological implications of Antarctica's desert status are profound. Unlike the hot deserts, which support a surprising variety of life adapted to extreme heat and dryness, the Antarctic desert is almost devoid of terrestrial life due to its extreme cold and ice-covered landscape. The majority of Antarctic biodiversity is found in the surrounding Southern Ocean, where the cold waters are rich in nutrients and support a wealth of marine life, from krill, a crucial component of the Antarctic food web, to whales, seals, and penguins. On the continent itself, life is sparse, limited to a few species of hardy microbes, mosses, and lichens that can survive the harsh conditions, as well as the insects like the Antarctic midge, which has adapted to one of the most inhospitable terrestrial environments on Earth. Antarctica's status as a desert also plays a crucial role in global climate and sea level regulation. The Antarctic ice sheet, the largest single mass of ice on Earth, holds around 90% of the world's fresh water. Even slight increases in the melting rates of this ice due to global warming could have catastrophic effects on global sea levels. Furthermore, the white surface of the ice reflects a significant amount of solar radiation back into space, a phenomenon known as the albedo effect, which helps to regulate the planet's temperature. Changes in the extent of the ice cover could therefore have profound implications for the Earth's climate systems. The recognition of Antarctica as the world's largest desert challenges us to reconsider our perceptions of what deserts are and where they are located. It compels us to appreciate the diversity of Earth's landscapes and the extremities of its climates, from the hottest to the coldest. This understanding not only enriches our knowledge of the planet's environmental and ecological complexity but also underscores the importance of protecting these unique and fragile ecosystems. In the face of climate change, the conservation of Antarctica and its surrounding oceans is more critical than ever, not just for the sake of the continent's biodiversity, but for the health of the entire planet. Antarctica, with its vast, ice-covered desert, stands as a stark reminder of the natural world's beauty, resilience, and vulnerability, urging us to act responsibly to safeguard our global environment for future generations.